Good morning and welcome to the Python course. There are a lot of Python course, but what makes it probably the difference is along with the Python video, we'll be having practical and the tutorial ready. So if you see, this is the site what we have. It's called sretoolkit.com. So over here, if you come, we have organized the things in a multiple way. One is the blog. Okay, you can search the topic Python and you get everything. Okay, another one, if you can come to tutorial, you get the learning path, and over here you come select the Python, and over here you get that particular tutorial. Okay, today we'll go through the Python programming, pre-Python related topics. Okay, I'll try to make everything as short as possible or as needed. It should not be too big videos, but to the topic, because you can access this particular site, which is sretoolkit.com. Let me write sretoolkit.com. Okay, you can get it to rest of the things, but for clarity, let me repeat. You go to learning, select the learning path, Python, and come over here, the Python programming learning path. Okay, it's still work in progress site. We are developing with the rest of the information, rest of the content, and this site is also free for anyone to log in, write their content, and they can teach. Okay, so the easier part, I believe, would be not only you can watch the video, you see few of the practical things what we do, and you can follow back the topics what we have. Okay, hope it's visible. If not, let me increase this font. The today topic is pre-Python, right? So pre-Python is something just to understand what is the difference between quick small topics on computer related items, right? So let's go through these topics. Okay, binary. What is binary? Okay, so binary in the computer world, right? We have two states, 0 and 1, which is power is not there and power is there, or electricity is there or not there. Because we have only these two states, it's called binary. Okay, what is bit? It's the smallest unit, the 0 or the 1. That's called bit. What is byte? The 8-bit combination is called as byte. Okay, but question need to be there, like why 8-bit, why not 16, why not 32? Okay, so if you go through 2 to the power 0, 1, 2, 3, 4, 5, 6, all those things, right? You can see that you get 256 combination when you do 2 to the power 8. Now the 2 to the power 8 combination of 256, you get most of the English alphabets, all small to capital Z, everything plus all the basic need. Okay, now each of these are called as character, but the mapping between this small z and capital G or small a, capital A, all those things, it's called as ASCII. You can refer this as this. We can call this one American Standard Code for Information Interchange. So this will be having the mapping between what is your binary value and how exactly these are the binary values, these are the decimal values, right? So if you see, the map is happening between capital A is represented as 65 and small a is represented as 97. These are the binary value, this is the decimal value. You can also see octal and hexadecimal. So these are there just to narrow down the density of the letter would increase once you go for hexadecimal. Okay, so this is how it works. So if you see one simple example, let's go through the example this, right? So this is VS Code. We'll go through how to do this, but most of the time I believe should be aware of how to do that. Just in case if you need help or video only on this or documentation, let me know in the comments and I will work on it. Okay. So this is interactive Python notebook I have given. So you click over here. We can go through this one also if you need it. Just let me know in the comments. Okay, I'll do this one. So let's say if I do compare, okay, A, which is capital A, is greater than capital B, sorry, small a. It doesn't make sense, right? Comparing two letters. If it is two numbers, that makes sense. But if I go ahead and play this one, right? Okay, it says false. How exactly do you think it's deriving? Okay, if you come back to the ASCII table, the A represents 65 and small a represents 97. So if you see, this is the comparison between, they are converting this one to the ASCII numbers, decimal numbers, and ASCII table decimal number, and then they are comparing with this one. So this is the logic why capital A is smaller than small a. Okay, so that's ASCII. But what is Unicode? So when they started everything, right, it comes from basic English, right? Later on, everyone says that, okay, we have so many different languages in the world. That should be identified. And that's where the Unicode comes. So let's search what is Unicode number would look like. Okay. So it will not be having a table because it would be too many things. Unicode version 17, that 297,000 assigned character. Obviously, I'll not be able to do any Unicode on this, but you can search what is Unicode chart and a little bit on that one. We'll see more practical on that, but that's exactly the Unicode. Okay. Now have a little bit understanding between RAM, hard disk, okay, ROM, processor. So the whole computing happens on processor, right? But the data stores on hard disk. Okay? So whenever you save something, it goes and resides under the hard disk. But so we can directly read the data from hard disk and do work on processor. What is the need of RAM? It's like this. If we go for an analogy, right? Let's say we have a hotel where you can find people with or let's say you have a big shopping mall, right? A really big shopping mall. So would you like to have something, wait for people to come by walk, or would you prefer something, a small car where you can travel between them? So it's all about RAM, right? So the RAM will not keep the direct data, but as it is way faster than hard disk speed, the processor don't have to wait much, and that's the reason behind why we have RAM. We can also find what is ROM. So when a system starts, right, it looks for a very specific small program just to identify where the operating system is there, and those small programs are written on ROM. Okay, it's called read-only memory, but technically it's flashed, right? So if you want, you can flash the small code which have very specific tasks, and those kind of data stay on the ROM. Okay, processor is for processor everything. This is one of the small analogy how exactly you will identify what are the parameters you do or check when you buy the mobile phone, and how exactly it's related with your computer. Small analogy about. You can also explore what are the different disk type. Okay, So instead of buying a 1 terabyte regular hard disk, a SSD would be far quicker when you start up the code. Okay. So you can check what is partitioning when you do a little bit segregation of the hard disk. It's called partitioning. Okay. So this is again how exactly you represent the data. When if it is binary, you read from actually right to left, not the other way. Okay, so it would be 0 1 1 1 1 1. Okay, and if you do the power table, it's 2 to the power 1, 2 to the power 2, 2 to the power 3, 4 5 6 7 8 9, and 2 to the power 10. Okay, so one of the questions usually come is to understand if someone says like what is 2 to the power 24 in a normal mathematical way. So how exactly you do this? So let's see, right? If we do 2 to the power 10, okay, let's say print what do you say, what we will get? Uh, 2 to the power 10, right? Sorry, like this. Okay, I'm not doing any editing because for now I'm focusing on the content rather than beautification. Might be in future. Okay, sorry about that. So this is where you see, right, 2 to the power 10 is equal to 1024. So if someone asks what are the questions, let's say the question come, let me make this one down. Let's say question, quick question that you need to do over the okay, over the brain. How you will do that? Okay. What is 2 to the power 22 or 24? So if you do this directly in your brain, that would not be easier. So what you can do, if you understand this one, okay, you can see 2 to the power 10 into, which is again in computer form, 2 to the power 10 into, in the form, we can convert this one again. So let's do a bracket also. 2 to the power 10 into 2 to the power 10 into 2 to the power 4. So if you break this one, it would be easy for you. How exactly you will break this one? Okay. So you will break it like this. The first one is 1024. Okay, into 1024 into 2 to the power 4 would be 2, 4, 8, 16. 16. So in the rough brain, if you see in the rough calculation, we would do 100 into 100 into 16. That would become 16, and if you see, we get 6 zeros. So this is how actually you calculate the questions. Let's say if someone asks 16, so it would be 1024, which in your brain you can say somewhere around 1000, and 6, which is 2, 4, 8, 6, 2, 4, 8, 16, 32, 64. So 2 to the power 16 is equal to somewhere around 64,000, right? So exactly 65,536. If you do from 0, it's 0 to 2 to the 65,535. That's where your computer ports and everything works on it. So one more thing, actually I started my career from a Linux system admin. So more or less the teaching would be towards supporting the administration and those kind of profile. We'll go through most of the generic things, but might be my example or whole thought process would be similar to that one. So if you are onto the system admin side, it would be easier for you to follow along with. Okay. What next? The question is this. You can search for rest of the things, but that's pretty much for today's session. Okay, you can come or next session will go for the Python fundamentals. This one is what we'll going through. Okay, and hope that's pretty much for this particular video. If you want a little bit more on how to install the VS Code, how to configure the Python interactive kernel or Jupyter notebook, those things will go through. But for now, yeah, thank you and have a good day.